Hello and good day, Algebra. We are moving on in speed runner style fashion to CO21. And we spent PO20 talking about slope. We identified slope on the coordinate plane. We're kind of doing the same thing here, only now we're also adding to that what's called the y-intercept. And you should have been introduced to the y-intercept last year. Essentially, what is the y-intercept of a graph? Or are we all learning something new? Caitlin? Yeah, it's where the line intercepts or intersects with the y-axis. So our ultimate goal here, our big picture thing, is slope-intercept form. Okay, which, if you recall, is y equals mx plus b. Okay, and actually, hold on. This should go down here in the key point. Sorry, I wrote in the wrong spot. That's okay. That's okay. Whoopsie-doo. Y equals mx plus b. The definition of slope-intercept form, it is the standard form of a linear function. Okay? The standard form of a linear function. When you have an equation in slope-intercept form, you know that it is a linear function because it has slope. And if something has slope, it's got to be a linear function. We talked about that. Okay? The slope. Who remembers how we defined slope? Yes. We're going to write that again, because the more you write stuff, the more you remember it. How a line moves across the coordinate plane. And our little fancy abbreviation for that is sometimes when you speed run, you make mistakes you normally wouldn't make, right? Rise over run. Well, good morning. Oh, that was fun. Okay. How a line moves across the coordinate plane. Rise over run is our abbreviation. The y-intercept, as was so correctly defined earlier, is where a line crosses or intercepts or intersects the y-axis. Okay. Now, I want to point out some difference in language here. For slope, we use the word how. Okay, it describes how something. The slope is not a location. Sometimes kids like to write slope as an ordered pair, thinking it's like a place. It isn't. It's how it does something. Remember, we described slope as a rate or a ratio. Okay, whereas for y-intercept, we use the word where. The y-intercept is an actual location. It's an actual point. So that's one difference between the y-intercept and the slope. The y-intercept is a location. The slope it describes something. Okay. Slope-intercept form y equals mx plus b. It's that m variable that represents the slope. Why do we use the variable m for slope? Yeah, Paisley. It's how it moves across the coordinate plane. Okay. Also, little known fact, when math was kind of being first discovered, developed back in the old days, it was actually called MLOPE. But then with language changing over the years, it kind of developed into slope. But the reason why we use m is because it was originally called slope, and also because that's how it moves across the coordinate plane. The b variable in that equation represents the y-intercept. And who knows why we use b for y-intercept? That seems kind of odd. Nathan? Barney? Not Barney. Good guess, though. No one's ever guessed that before. Ethan? It's where we begin when graphing, right? When we, folks, when we use this to graph equations, it's our first point that we plot. It's where we begin. Also, little known fact, when math was first being developed, taught, it was actually called the y-intercept. The y-intercept. But then over years, as language was developed, so intercept, the y-intercept, yeah. Okay. So, when 3, 2, 1. When you are given an equation, you should start to recognize this form as slope-intercept form. Y is by itself. You have an x term, and then you've got a constant. What our goal today is essentially, what is the slope of this line going to be? What is the y-intercept of this line going to be? How does the line move across the coordinate plane? Where does this line cross the y-axis? So what is the b variable value? What is the y-intercept? Jocelyn? 0, 3. Okay? That b variable being the y-intercept, where this line crosses the y-axis, is going to cross it at positive 3. How about the slope? How does this line move across the coordinate plane? Yeah. 7 over 1. I'm glad you caught that. That 7 can be kind of tricky because slope is a fraction, but there it's not. Remember that any integer can be written as a fraction by putting it over 1. Okay? So is this line pretty steep or not so steep? Pretty steep. It's going up 7 for every 1 that it goes over. Up 7 over 1, up 7 over 1, up 7 over 1. If you can visualize that, it's going to look kind of like this. Up 7 over 1, up 7 over 1, up 7 over 1, something like that. Okay? But knowing where those pieces are in the equation, that's the key here. The next one, y equals 3/5 x minus 6. We recognize slope-intercept form because it has that y by itself. We have an x term and then followed by a constant. What's the y-intercept? Same thing as the b. I just wrote it in its synonym. Paul, -6. Again, this is a location, right? It's going to cross the y-axis at 0, -6. And what is the slope? How does it move across the coordinate plane? Finn, what is the slope of y equals 3/5 x minus 6? What term is in the place of that m variable? Would you like a hint? Mm-hmm. It's not y, it's not x, it's not -6. There you go. 3/5. Okay? This line will move across the coordinate plane at a rate of up 3 and over 5. Again, notice our y-intercept is a location, right? Our slope is not an ordered pair. Okay? It describes how it moves, not location. And then lastly, y equals -7/2 x plus 3. Our y-intercept is where, Charlotte? 0, 3. Our slope, how it moves across the coordinate plane, will -7/2, right?
How would you graph that? Because you don't know if it's actually 7 or the 2.
It doesn't make a difference. Typically, when you are using slope to graph and it's negative, you put it with a rise, but it wouldn't matter because going down 7 and right 2 to get from point to point is technically the same thing as going up 7 and left 2, right? Our lines would be the same, okay? But it's standard to put it with the numerator, so you're going down and then to the right. If you're given a coordinate plane, no equation this time, you're given a coordinate plane, what is the y-intercept and what is the slope of that first line there, Colin?
The y-intercept is 0, -1.
0, -1. And How do you know that, Colin?
Because there's a dot on the y-axis.
Yeah, knowing the definition of the y-intercept means where it crosses the y-axis. We have a point that identifies where it crosses the y-axis. That value on the y-axis is -1. Okay. Finding the slope now, we kind of have to go back 2 objectives. 19 and 20, really. What's the slope of this line? Paisley? Up 1 over 4, I think, right? Right? Up 1, and then 1, 2, 3, 4. Okay. How are you supposed to know what?
How are you supposed to know where it starts? Because it could have started at the dot.
I did start at the dot.
Remember? Right.
You go from left to right. Yep. Next one, slope and y-intercept. This one does not have a point on the y-axis, but we can see where it crosses. Nick Sundorf, what is the y-intercept?
The y-intercept is at 4.
At 4. Okay. Written as an ordered pair, 0, 4. And what is the slope? You are given 2 coordinates. What's our rise? What's our run? Chase?
1 over 2.
Ultimately, after simplifying, you get 1 over 2, right? Up 5 over 10 reduces to be 1 over 2, which means the rate at which this line moves, up 1 over 2, back in the line, up 1 over 2, back in the line, up 1 over 2, up 1 over 2, up 1 over 2, makes that nice staircase that slope does. Questions on this? Okay, your homework for tomorrow. See, folks, we did it. Look at us go. You are to plot the ordered pairs on the coordinate plane, connect them with a line, and then identify the slope and y-intercept of the line. So you're plotting your own points. Then once you do that, it becomes exactly what we did in the previous 2, where you've got the line on the coordinate plane, and then you identify the slope and the y-intercept. Questions, comments, concerns, complaints, comments, congratulations, or criticisms? Do you think we can play the number game again tomorrow?
Yes.
Will you self-destruct?
No.
Yes. All right. That's how you math, folks.